We got one. We got two. Come on, Twitch, you bastard. Twitch always takes so long to load. I don't know why, like, I'm all washed out right now, too. Like, my exposure is off. Oh, you know what I forgot to do? I forgot to re-export. That's fine, let's do that. There's something. Okay, all three are going. 22602.7. What do I even call these? Is that it? That is not it. Retail course, not retail course. Okay. Forbidden, Jesus Christ, what the? Why is everything anything? What is your malfunction? It's probably something stupid. Mod security, Jesus Christ. I hate when, like, I was gonna just put this on a web page and so I can read it off, and it is freaking mod security. Okay, god damn you. It's like it's always something, right? Okay. etc Apache. 00 default.conf. That's the wrong one. What is it again? Directory. Sec. Roll engine off. Okay. I'm sick, by the way. All right. Directory var www. File? Yeah. That is right, isn't it? Read link. Whatever. Okay. 1 second. Roll engine off. Okay, there we go. Now I can actually read it. Oh, great. It actually just exposed that part. Okay, good. That means I don't have to go digging through it. Coffee. can begin to prepare to proceed to begin. Of course, you get the coffee on the paper. Good job, idiot. Oh, I forgot to do this. I don't like how in Streamplace you have to like explicitly announce, because I always forget. All right. Oh, and I actually have to. Should do the actual YouTube link. It's one thing I have not appreciated fully is like just how much all the chores that you have to do when you're streaming. It's like it would be nice to just be able to queue them all up. Where are we here? Hey. Hey. All right. All the chores for streaming. Okay, just gonna make sure that. Yep. Okay. So, REST. Well, actually, I do need to think about whatchamacallit. I do need to think about a trailer of sorts. So, I would say like basically like the reason to look at REST, like why, like what this is a series of lectures, more effectively, about REST as Roy Fielding wrote in his dissertation. And I think the reason why I, sort of the proximate reason why I have taken an interest in this is because I've been adhering to the principles of the REST dissertation for a while in my own work. And I have noticed like a gap, effectively. When you hear about REST, normally it's RESTful APIs. And that has a very specific meaning in the web development community, and it's got to do with, endpoints having different, request methods and such. And so it's not wrong, it just misses most of it. And so the goal is to sort of look at the actual, basically, like, I've read the guy's piece. It's not that long. It's only about 162 pages long, if you don't count the references, or even if you do. I can't actually remember. But it's not a very long dissertation, as dissertations go. But REST contemplates it's sort of a vision of networked information systems, networked hypermedia systems in general. He sort of like steps back and he goes like, the web is only one possible networked hypermedia system of, potentially many. and says, okay, like, you know, what are a set of constraints, what are a set of desirable and useful constraints that we can apply? And this work would have been done in, you know, the late 90s. But what constraints can we apply to the web, or in this case, just if you were designing an imaginary networked hypermedia system from scratch, is kind of the way that you have to think about it. So, like, what are constraints that are sort of desirable in that? And he goes through a bunch of them, and the thing that he lands on is this thing he called representational state transfer. And it has to do, so if I was going to say that like the key elements of it are really this sort of notion of a unified interface and a layered system, I think, are the two key elements of it, which, you know, doesn't sound like he's talking about APIs. And so, you know, like the word API, I don't even think like shows up once, at least in the context of a web API. I don't think it even shows up once in the dictionary. I'm going to actually just double check that right now. I haven't started yet, by the way. This is not start. This is not a. So let's just go here for the PDF API. We're just going to network-based API. Switches away from other middleware when it uses HTTP as a network. That was the case. The library-based API. So he's got a section, architectural lessons. Not really. Definitely like acknowledges the existence of them, but doesn't. I mean, I'll probably reread this bit. It's been a while since I've actually read the thing in its entirety. I think the thing is like, if you, and this is something that I have yet to, because it's going to be like a dank thing to go and pursue, is like what the actual, like how this got transmitted and picked up and was like, you know, this is for APIs, and only for APIs. Is a little bit mysterious, like how that actually got, like basically every other, you know, idea behind it kind of got lost. But deployment experience interesting. Interesting. Yeah, I have Anyway, okay. So this is still not me starting. This is not even me. This is me kicking the tires on my brain. And warming up. I should actually just warm up in general. Like, I should just, like, build that into this process of just, like, whenever I stream, I should just be, like, spend the first 10 minutes just being like, okay, where's my brain? As opposed to just, like launching directly into it. Still warming up. Where is my brain? That's not what Excusez-moi. Learn to type. Okay. Bleh. All right. So, just I'll reiterate. So REST is not just about APIs. It is about really like Fielding, when he wrote, he's got an entire PhD dissertation on it. Fielding is the guy who wrote a bunch of the HTTP specs, wrote the Apache API, and wrote a bunch of other guts of the web. And he wrote a PhD dissertation about, it was called Architectural Styles in the, what is it called? Architectural Styles and the Design of Network-Based Software Architectures. And if you ever read it, It's only about 162 pages, but it contemplates networked hypermedia systems in the abstract, of which the web is but one possible implementation. So it's a much, much bigger and more profound idea than APIs. And so the reason for revisiting it now has to do with, well, I mean, it's been informing my work for the last 2 decades, but also I would say the reason to look at it now is that a lot of the things like that just would have made it more powerful, because Fielding wrote it. You know, the stamp on the thing is 2000, so he would have been writing that dissertation like for years prior to that. You know, he would have been writing most of the bulk of it in the late 90s. So that's like .com 1.0, like Y2K zone. And so the idea of just looking back at it and just being like, okay, like, you know, what was missing to make this thing a workable, you know, a workable strategy or set of constraints for the entire enterprise of the web, as it were. And, you know, and that's basically where I'm at, is I'm like, you know, there was like, in order to really, and this is called, the series, I'm calling it Semantic REST. And so, oops, was it the wrong one? That's the screen only slide deck. That was 4. Okay, whatever. Anyway, so the idea, I guess, I mean, what I'm calling it Semantic REST, and basically my argument is a bunch of stuff was missing, like that just hadn't been invented yet, and it was kind of, you know, and it's like you can't blame the guy, you know, like for you know, missing stuff even at all, because it was kind of out of scope anyway. And so I'm just gonna get something on the screen from my face here. I'm just gonna get the script on the screen so that I can read it off, because this is still a scripted thing. But yeah, so the idea is, you know, so basically my thesis, my argument here is that the REST as it was at the time was missing stuff. Like, it just, you couldn't, I mean, yeah, he would have had to have invented an entire other layer, you know, of semantics. And so this is the first one, is just like the resource, the information resource, as a load-bearing fiction, as a thing that is, oh shit, that just went away. 60207 retail course. It was loading, and then I hit the refresh button, and it refreshed to nowhere, because it made a giant browser window on my screen, which I did not want. Okay, I am waiting for this to load. Nothing can be simple. Why are you loading HTTP and not HTTPS? Jesus Christ. We are just waiting for my website to load. I gotta say, like, my stuff is real bogged down at the moment. Retail courses. We are waiting for a static web page to load. Is that thing moving by itself? God damn it. Nobody said you could do that. Or is that not? Huh. Time to see slides. Manually use hotkeys. What is your malfunction, man? Just load a web page already. I need to be able to see the script. It's like just sitting there. Like I have loaded it. I have hit it. I've hit it with curl. I loaded it in another computer. It's just this other one is just not like it's just not loading. Come on, buddy. What is your malfunction? We are trying another browser. We are not trying another browser. We are just sitting. It's like bouncing in the dock. Is this thing just max the hell out right now? Yeah, we are waiting on loading a web page in 2026. A static web page, I might add. It is a file. Set Chrome as your default PDF viewer. How about that's not what I asked for? PDF. Just load. This is unbelievable. Okay, you know what? I'm going to kill everything on the second computer and restart it because I can't have this. Yet more technicals. Yeah, please stand by while I kill the browser and restart it. That'll be 10 minutes. Still not loading, by the way. I'm gonna open a window. It's freaking stuffy in here. out of focus. It'll be like that for the next freaking year. You did it. Wonderful. Okay, we are still waiting on the browser to clear out and so that I can start it again. I can't see anything at the moment because, of course, I just closed the browser. If anybody's chatting at me, I can't see it. Okay, force quit. Start it again. This is going to be like another 10 minutes. Great. Great. Oh, thank God. Okay. Wonderful. Watch YouTube is going to like make me freaking key in again. There it is. The web page that I waited 20 minutes now? Like, God. I was going to do this at 9 a.m. It is now, oh my God. I don't care, man. I don't care about all your AI stuff. There's finally some contrast. God. Yeah, I'm sick, by the way. We're still waiting on YouTube to load. That's going crazy. You can always, it's funny, like, when a camera can't fix on something and then you can hear it like grinding. It's like, I had the desktop camera going, like this guy. Okay, finally. Finally. No, we're still waiting for YouTube. Are we? It's just like... Well, guess we just wait indefinitely for YouTube to load. Streamplace is loaded, Twitch is loaded, YouTube is sitting there. Get out of here, get off the screen. What are you? Okay, are we ready? Like basically my setup is I have a second computer, the one that is not streaming, that is for the readout for the streams. But it is a vintage MacBook Pro, and it is slow. It's like fine if you don't have to change anything or do anything with it while you're going. All right. Are we ready? It is so chugging. It's like, don't do this to me. Okay. So, this is a timing test. That is why we're doing this. It's a timing test and a fit test for the slides. So, let me just start the clock. All right. So let's go to 4. No. What? Are you kidding me? 6, 7. Okay, whatever. Yeah. So I'm out of focus again. I don't love that. I don't love the fact that I'm also underexposed. But here we go. So this is the information resource as load-bearing fiction. It's the first of the Semantic REST series that I'm doing. Again, Semantic REST, I'm calling it that. That's a me thing. I think somebody else has used that term, but you know, REST, of course, was Roy Fielding. He wrote a PhD dissertation on it. My sort of thesis here is that a bunch of stuff that like really would have made it more powerful just hadn't been invented yet, because he put that out in 2000 was when is the stamp for when he defended it. So you know, it's been coming up on 26 years now. And you know, stuff has happened. And so I think it's worthwhile to revisit REST in that context, especially because it's so much more profound than just APIs. And so the first of this series is about information resources as they pertain to REST. And of course, like I was saying, REST is contemplates networked hypermedia systems like in the abstract, and has the web as being just like one possible implementation of that. So it's a very, very big idea. So the way that I organize this series is, and I can even just go to the page on that. So, you know, what I figured, oops, that's not what I wanted. That is not what I wanted either. I can't just, oh yeah, I just don't have what it is I don't have a hotkey bound to that. So I'm going to have to do that by hand, but, where are we here? Where are we here? What was I going to? Oh, yes, of course. So, yeah. So what I'm doing here is killing that. What I'm doing here is I am doing like just basically like a set of training seminars. Now this comes out of basically me repackaging it, a bunch of the technique that I developed from my own stuff in the last several years. And so this is what this is about is like, so how would you go about creating, you know, your infrastructure using these principles? And basically what I'm doing here is I'm making it so that you don't have to read this stuff. I've read it for you, and I've, you know, integrated a bunch of capabilities. So that's the value proposition here. But what I decided to do was like sort of a 7 lecture series. We can actually just go back to that. So what we're doing here is this guy. This is going to be just a little, basically a trailer. So all of the rest of these are what I'm doing here. So this is the, you know, the rest of REST. But the information resource as building block and load-bearing fiction, that is this guy. Anyway, oops. And I really have to fix the hotkeys on that because that's going to drive me mental. I don't actually know why it's skipping over that. Anyway, I don't want to think about it. So yeah. And of course, this is going to go away. I'm not going to be... If you're going to see this again, it's going to cost you. So there. All right. So I should really change this to say the thing about the loaded bearing fiction. But this, what is a resource anyway? Is fine. Yeah. So the purpose of this lecture is to characterize the information resource as a critical load-bearing fiction for designing networked information systems in general and the web in particular. My goal here today is to show you the contours of what an information resource is with respect to the web and provide you with a design language that you can articulate so that you can articulate those contours. So I'm going to start with a history and then I'm going to get into the structure. So this is the first series of the series I'm calling Semantic REST. So, an information resource is a thing or a place where you can get information from or send it to, or both. This goes far beyond web pages. So like a book can be an information resource. Actually, I need to go and get a prop. Actually, that's part of it. So 1 second. This is why I'm doing a test run. So, you know, a book can be an information resource. So can a telephone number, a particular set of geographic coordinates, even a person for that matter. And of course, all of these can be identified by URIs, except for people. Well, we'll talk about that in the, if you want to look ahead, though, it's HTTP range 14 is the thing to Google for. But we won't get there. What the heck? Oh, all right. Sorry, I just got a message added to a group chat that I had not. Oh, it's my friend in Tel Aviv. Okay, that's why. Okay. So where was I here? Yeah, so HTTP range 14. You want to look that up? You can. So if you want to be glib, you can say that an information resource is anything that can be identified with a uniform resource identifier. It's a way to identify resources that is uniform. If your particular resource is not on the list, you can just register one. Again, I'm going to do an entire lecture just on URIs. So watch out for that. Actually, I can't see the following slides here, so I actually don't know when to change them. So this is a test run. So yeah, I am going to focus though right now on the idea of a load-bearing fiction. So what the heck is that? So we know that when we compile C, it first gets transformed into assembly. The assembly statements then get transformed into machine code, which corresponds to numbers, which correspond to bits, which correspond to switches on CPU registers, which make up the parts of an individual processor instruction. And that is supposed to simulate a Turing machine, which has always been a theoretical construct and never a serious proposal for how to actually build a computer. The only thing is, computers have not worked like this in a while. Or more accurately, there's a bunch of stuff now between the instruction set and the actual voltages happening on little wires. But a computer's instruction set architecture is an interface. And the point of an interface is to present a consistent structure and set of behaviors, no matter what is going on in the background. In other words, an interface is a story. It's a fiction. That says story fiction. That's no good. So it's tempting to call this example an abstraction, but in the case of the instruction set, what happened was like one side of it stabilized while the other side got more complicated. So in a way, an instruction set is not so much an abstraction as a skeuomorph. Oh, no, okay, I have to do this slide. And a skeuomorph is like if you've never interacted with the term before, it refers to a feature or aspect of an artifact that like once had a direct relationship to its functionality, but like now no longer does. So like the rivets on jeans, the little handle on a jug of maple syrup, the stone columns, so like Doric columns are, they are in the shape of a wooden structures that were load-bearing before, but now they're not. The calculator or the notepad, I actually went and got all the assets for that. I just hadn't put it up. But like a calculator app, like you don't need a calculator app. Computer's already a calculator. Why do you have to make it look like a pocket calculator? That kind of a thing. Dial pad on a cell phone, right? Another one. The role of a skeuomorph is mainly semiotic, like it signals like what the artifact is for. Although as far as skeuomorphs go, like a CPU instruction set is particularly load bearing. It's like it could be something else, but like we've all been using this particular instruction set. Like you would mess people up if you changed it. So it's better that you don't, kind of a thing. And that's to have the continuity over time so that your code compiles and runs, etc. Does the right thing. So some interfaces are more representative specimens of abstractions than others. You take a language like Haskell, which is has the very specific constraint that all code must be a pure function, even the stuff that can't be. And for that, they use a mathematical trick called monads. And I'm only mentioning monads because you can't mention Haskell without mentioning monads. But Haskell uses monads for all sorts of things, like smuggling out side effects. I guess you can't see my mouse. Smuggling out side effects. Actually, I should make that work better. Anyway, it doesn't matter. Where are we? Yes. Smuggling out side effects is one of them. The point is, designers found a way to walk a tightrope between mathematical consistency and a fully featured programming language. This design decision does two things in particular. For one, it forces programmers to organize their programs so that side effect producing operations get bunched up and only happen in certain places. So when you this bit down here, can I do that? Yeah, this guy. But the second one is that in return for this, it confers certain guarantees about the software's behavior. So a given function applied to a given input will always produce the same output, which is a property, of course, we call deterministic. You guys know that. And this in turn gives way to a number of other desirable properties. So pure functions are referentially transparent, which means they can you can replace the input with a particular operand with its output. So you can just go through. This is actually not what's happening there, but this is just a. This actually would give you a warning if you tried to compile it, but because this specific case has to go above the general one. But I wanted to just like express that anyway, because I mean, yeah, you're for all if you ever saw all instances of increment 1 by 1, you can just replace with 2. That's basically what it's trying to say here. And then, of course, you can do that, and then you can memoize that. And, of course, memoization is just a particular kind of caching that happens. And it can happen automatically, or it can happen in, the runtime could do it, and if it doesn't, you can do it yourself. Where are we here? So, yeah. Means you only have to compute the function once and then just reuse the value if it comes up again. Even better, you get the underlying system to do it for you. This in particular form is caching. It's called memoization. Yes, okay, we did all that. Because all pure functions are deterministic, they can snap together like Lego. Two functions snapped together can be treated like one larger function, and this is especially powerful when functions operate over other functions. So then of course, all of this can be manipulated algebraically to produce the fastest running configuration. And of course, the underlying system can do that automatically, deterministically, it's just another function. So the fiction in the case of a language like Haskell is like, that's how computing has to work. It doesn't have to work that way because in principle, you can write anything you can write in Haskell, you can write in some other language. And of course, the mathematical purity is about as far away as you can get from punching instructions into a CPU. Like the Altair, the PDP, like you literally could plug in opcodes into the front panel of those things using switches. That you could actually, which would be enormously tedious, but you could do it. So another very familiar load-bearing fiction that most people in the audience will be familiar with is the fact that POSIX compliant systems like Unix and Linux and BSD, and therefore also Mac OS and just about every smartphone currently on the market, everything about the computer is supposed to be addressable as a file. It means you can open the file that represents your mouse and you can read the input stream off of it, or you can open the file that represents your hard drive and write some arbitrary bytes to it, although, that'd probably be bad if you did. But you could, and I have. So then there's directories, also known as folders, are typically implemented as files that consist of a list of other files the directory is supposed to contain, plus a spec of metadata, indicating that's how it's supposed to be interpreted. But it should be noted that files themselves are a fiction, because files are called files, because when they were made out of punch cards and then magnetic tape, they were literally filed, like on a shelf, or in a drawer, or in a physical archive. So people would write the contents of the punch cards onto the front of the box or drawer, like proto file names. Tapes with much higher capacity relative to the punch cards. Somebody had the idea to put a region at the front of the tape, which was just a list of the contents. Thus, the directory was born. Didn't take long for people to put directories inside directories, and that's how we get the hierarchical file system. So the innovation of Unix, actually Multics, was to make every part of the computer behave like a file. This made it legible, and you could manipulate it with little programs that you could connect together in pipes. And then you can glue those little programs together with scripting. So again, you got this sort of Lego-like ad hoc tooling, but you had to know what kind of data was going through the pipe. So files and file systems are just another interface that for accessing data on persistent storage. The situation evolved out of a sequence of needs and affordances. And, a file system is a very simple database. You got a name, location in the hierarchy. You got a sprinkle of metadata depending on the system, almost always the modification time, sometimes ownership and permissions, sometimes some kind of special status like an executable bit, and then you got a blob of arbitrary data. And, in some file systems, you've got other things like what application the file belongs to. You can mount file systems from other computers using any number of network file protocols. You can overlay file systems using UnionFS. You can even fake up a file system from some code, arbitrary data provider, and using something like Fuse. But a file system isn't the only way you can save data to a hard drive. It used to be possible, for example, to configure Oracle to install its databases onto raw hard drive partitions. Presumably you still can. I haven't tried in a while because I haven't messed with it in a while, but that would make the database run faster because it would bypass the overhead of the file system. There's trade-offs like maintainability, but again, you can do it. You could just... I found that if you would set the block size of the database to be the same as the block size of the file system, it runs noticeably faster than if you don't. Probably still the case, or maybe it isn't anymore because it doesn't matter. But the point of files is that they're just a segment of bytes. And even the 8-bit byte, is another arbitrary, not because quasi-arbitrary. There's a reason why it's useful. But it's just a convention, right? They were all sorts of sizes once upon a time. So what a file means, though, is nevertheless determined by the application that created it. And the role of an operating system was to provide hardware resources to applications through a unified interface. And it was up to the applications, rather the authors of the application, to decide what to do with those resources. So you put an entire database inside a single file and you say nothing else touch this, the database engine will manage it. And then the file format and its semantics would be opaque to everything else unless the application developer standardized or at least publish the specification, which they typically didn't. And so what we see nowadays are a lot of managed databases on top of file systems that interface through provider APIs. Like that's basically how all smartphones work. Also, if you talk to people who teach computer science, they will have stories about like how they routinely encounter students who have never interacted directly with a file system, like even at the graduate level, which is wild. They just search, apparently. But anyway, so why this is relevant is because the web started off as files and directories, but very quickly grew out of it. It was obvious very early on that it would be useful to run code on a web server. And in the way before times, if you wanted to make a web app, you had to hack it directly into the server and then like recompile it. You had to write it in C. This is very cumbersome. You can make very big things. So the Common Gateway Interface was invented in 1993. What did it do? I think it's actually pretty clever. You take the basic elements of an ordinary command line program and you map them to an HTTP exchange. So like HTTP headers and other metadata about the request and the connection and the server, they go to environment variables. The positional query string goes to the argument list. These don't get really used so much anymore, but like if you just saw like question like A plus B plus C on a URL, like that's what that is. That was a thing once upon a time. It's not so much a thing anymore. What else? Positional, yeah. So request body goes to standard in, response goes to standard out, and logs standard error goes to the log. This made it possible to write trivially simple programs in any language you wanted and then put them online in seconds instead of having to write them in C and recompile and restart the server. And the pattern was that you would have a mostly static site, save for a handful of purpose-made CGI scripts. And web hosts used to have like a CGI bin directory that would be aliased into the document root. I'm pretty sure people thought the bin was like a bin, like a bucket, like a tub box, when it was short for binary. But it kind of was like a bin in the sense that it did fence off the executable code from the rest of the site. It's worth noting that it was possible, even way back then, to trunk an entire website through a central CGI script, just like you would a contemporary MVC framework. I just doubt anybody did that. And also the central problem of CGI was that like a CGI script would have to load up, run, and then exit with every request. And this sharply limited what you could do with CGI, and it made it extremely difficult to scale. So the situation was eventually palliated by fast CGI, SCGI, mod Perl through Apache, CGI, and WSGI, etc. for Python. And these, through one mechanism or another, would preserve the CGI interface, but keep the code running across requests. Followed by that, or actually contemporaneous to it, with server-side includes, these emerged from the fact that very early on it was clear that it would be desirable to reuse chunks of web pages inside other web pages, as well as execute code. So server-side includes, which is the top one, of course, lets you mix static and dynamic elements, and the locus of control for that was the document root. This mushroomed into what some have dubbed the callback paradigm, or I would say interpolation paradigm. And, so like PHP, ASP, JSP, Cold Fusion, and there's like a bunch of also rans like Miva, Merchant, and stuff like that. And of course, a huge chunk of the web is made this way, continues to be. WordPress, which runs like 40% of all websites, was basically like this until they smartened up. They started to use like a single router, or whatever, central scripty thing. Not only that, because executable code goes into the document root and bypasses OS security measures, particularly in the case of PHP, your attack surface is only the entire website. I skipped over the part that the problem with this paradigm is that anybody who lived through it can attest it makes a colossal mess. The thing that I said about PHP, this is a test run, by the way. Not only that, so I'm inclined to say that the security thing was just part of the mess. The salient point here, though, is that the application logic would get mixed in with the content, which in turn would get mixed in with largely benign activities like transclusion. And importantly, these were files that you would upload to the server's document root. Of course, if you're not familiar with the term, but I'm sure you must be, is that a document root is like the part of the file system that a web server can see. It gets mapped to the address, mapped directly to the address space, I should say. So they show up as URLs, and they would execute, whenever something came along and requested it. So if you're a hacker, all you got to do is figure out a way to get a file into this space, because then you can go around the other side and hit the file that you just uploaded, and then it does its thing, and the website is now owned. So 2004, what happens? Model view controller. To tame this mess, people start designing web apps as unitary packages that would interface through a central executable. They cribbed the model view controller paradigm for desktop apps. So there's a model where the data lives. There is the view where it would be rendered, in this case to web pages, and then the controller where the application logic is housed. I'm actually not sure why it's MVC and not like MCV, because like the C is between the M and the V, but I don't know. I don't know why. It'd be interesting to figure out why that is. This started with Rails in 2004. Soon after that, every popular programming language has at least one MVC framework. There's often several of them. An MVC framework usually owns the entire address space of the website, so that kind of pins you to a stack. It is further exacerbated by ORMs that wrap SQL databases, so like people would stick logic in there that like really belonged in the database, triggers and complex integrity constraints and stuff like that. Likely because they were using a database like MySQL that couldn't handle that. Or otherwise, it's a terrible experience to implement in the database natively. Like Oracle PLSQL, like if you ever have to touch that stuff, my God. But Postgres is a little bit better, but it's still not great. Even though that is absolutely where that kind of logic belongs. It's also exacerbated by the view layer because there's like a zillion different template languages that were nevertheless mutually incompatible. And page composition happens on the server side, so you get a zillion different like transclusion techniques. And then most recently, we have the sort of microservice/serverless paradigm. Your Docker and your Kubernetes and whatever. It's at least theoretically less of a pain in the ass to mix backends. You got lots of JSON flying around. Page composition seems to happen in the client side now with like React and stuff. So you're actually like serving components over HTTP and then compiling them on the client. just as an aside, you could do that with XSLT for 25 years. Except they're trying to get rid of that, and they probably will. Anyway, okay, just to recap though, where are we here? Yeah. The whole point of stepping through this history is to think about like what you're delivering as a developer. Like somebody tasks you to create a new feature, like what artifacts do you imagine coming out of that? Like in the CGI era, for instance, you might create a script or you might modify an existing one to augment an otherwise static website. In the interpolated era, your target would be one or more files that would map one-to-one or at least close to one-to-one, like there might be includes or something like that, to web pages. In the MVC era, your work product would begin with an individual controller, like a method in a file probably, which would then correspond to a subregion of the website, which you would pull together whatever changes were necessary in the view and the model. And in the microservice era, you deliver something that would effectively be understood as its own little server, and that responds to at least one URL via at least one request method. So this is why I think we finally arrived. You write one of these things in like whatever language that best supports what you're trying to accomplish. So like say you wanted to make a Sass filter. And by this I mean Sass, like the CSS macro language, and it's a tenant preprocessor. So the only version of Sass under development is written in Dart. Now, I don't know about you, but I don't have anything else written in Dart. So instead of trying to get bindings, to get your not Dart MVC framework or whatever, it'd probably be easier to just create a small like Sass as a service, a Sass. I mean, for all I know, somebody's already done this and maybe several times, and you just pull it off the shelf. So that's one aspect. Next, and you should probably get another slide in there. Yeah. So next is you can group together resources with other resources that are unrelated, say for the fact that like they use the same programming language and or libraries, or they require the same privileges, or they like all experience similar loads, or whatever other reason you have for clumping them together. Like they don't have to be together for any other reason. And then finally, you have your pick of like how you want to deploy it. So like Docker, Kubernetes, Amazon, Google, Microsoft, HeroQ, Vercel, Vanilla VPS, Raspberry Pi, Smart Toaster, whatever. And microservices aren't your thing, don't sweat it. Like the point of this discussion is to underscore how we've evolved our understanding of the medium. So just to reiterate, the web absolutely started off as a thing for putting files online. URLs indeed evolved from earlier representations of remote file paths. It's not controversial to say that they were originally meant to represent actual files and directories. But then some of those files became programs that emitted output that looked like other files. And as time passed, the relationship between the program and its file-shaped output became increasingly tenuous. And the way the technology evolved, URLs have almost no direct relationship to file systems anymore. In fact, beginning with Apache, the part that maps URLs to the server's file system has been just another module for 3 literal decades now. And that regularly gets bypassed by even WordPress these days. So I think it's time that we bring our mental models about just what an HTTP resource even is into alignment with what Roy Fielding and Tim Berners-Lee were imagining some 30 plus years ago. And I want to really underscore this. RFC 2068 and RFC 2616 are both 30 years old this year. Tim Berners-Lee came up with this ideas very, very early on in the incept of the web. So what do we got here? Yeah. We just went over how you as a developer would have gone about delivering web functionality over 4 different epochs of the medium. But I want to look at it from what it looks like from the outside. because that's what this lecture is about. It's about framing the information resource as an interface with a common and predictable set of constraints. So like HTTP fundamentally deals in terms of messages. That's to say pairs of requests and responses, which we'll just call that like an HTTP exchange. And the response to a given request could very well reduce to like traverse to this directory, then open this file, then chuck its contents down the wire. In practice, this is probably by far the single most common kind of exchange. But there are a lot more things in the ecosystem these days that do not work that way. And products, techniques, and frameworks are popping up left and right to take advantage of the fact that, albeit mostly in subtle ways, that HTTP deals in terms of messages on a network rather than files on a hard drive. So whereas a file can be understood modulo, symlinks and I guess hard links too, as a mapping between an identifier, so like a name and location, and like a single byte segment, one exact string of bytes, basically. Whereas an HTTP resource is a many-to-many relation between a set of identifiers and a set of representations. So, that is to say that an HTTP resource is a multi-dimensional object. And again, this is something that Tim Berners-Lee came up with in the 90s. The details in the implementation were worked out by Fielding. It's been part of the HTTP spec since RFC 2068, which is the first cut of HTTP 1.1. Again, first drafted in 1995 and published in 1997. So what are the dimensions anyway? The dimensions along which a representation of a resource can vary are the request method. And we forget this because servers are where the information is most of the time, and most of the time we're dealing with GET. But GET is just one request method that you would have to consider when designing a resource. In fact, I think this is where the popular understanding of REST comes from, this sort of notion that there are more than one request method. Anyway, the next dimension, which is of paramount importance, is the content type. This is controlled from the client with the accept header. It's going to be really mundane, like serving a WebP instead of a JPEG, to save a few bytes. But it can be really powerful if the same content could be expressed in two different syntaxes. So like, say, HTML and JSON. If you did that, you wouldn't need to have an API that was separate from your website, and this is something that I've been taking advantage of for a really long time. The next one is natural language. So that's controlled by the accept language header. Something I had a lot of experience with this one back in the early 2000s. So we used it to transparently marshal content in 15 languages on 120 websites. So the URLs would stay the same, but the language would be different depending on your locale. And we made it so you could override that with a path segment, and then that would rewrite that header. So you say your locale is in French, you go to the site, it's in French, but if you want it in English, you click on the link and it goes to like /en/whatever. But under the hood, it takes the accept language header and just like plugs en at the front of it. And everything else about the site works normally. In other words, that path segment doesn't actually exist anywhere, but the intervention was to do that was only a few lines of code. The next two dimensions are kind of boring. One is character set. This is mostly useless these days since everything is UTF-8 now, but like 20 years ago, it sure wasn't. You might save a few bytes in certain contexts, but it's not worth the candle to implement. What you'd save in bytes, you'd probably lose in cache misses anyways. But if you insist, this one is controlled by the accept char set header. Encoding is more important, but it's usually handled automatically these days, just in server modules. That's controlled by the accept encoding header, but in practice, it means compression. It doesn't have to, though. Like, there might be some interesting things you could do with this header to trigger other kinds of encoding, like base 64. But of course, like if that made any sense to do at all, you would probably be doing it inside your infrastructure somewhere, like some kind of internal service. Like you would fire something at it, and it would come back. You can also stack encodings as well, so you could do like base64, then gzip or something like that. Another important one is whether or not the request has been authenticated and possibly by whom. This is easier to do when your app is monolithic, or at least you have access to the inside of the request object. If I was going to do this with microservices, I would rely on JWT and the authorization header. I also just want to footnote that the authorization header is widely recognized as a misnomer. Like what it's doing is authenticating the request, not authorizing it, because that's not the client's job to authorize. That's the server's job. But the reason why you would care if the resource was authenticated is so it can return a response that's specific to that user, that client. And the resource itself wouldn't have to care per se about whether that user was authorized to access it, because you could do that determination before the request even touched that resource. I want to also highlight like a relatively new dimension, which I'm excited to start using, which is the response preference. So RFC 7240, the prefer header, has to do with signaling that the resource should respond with modified behavior. So examples would include like whether or not to return a representation or just a header, whether to wait for a synchronous response or otherwise detach and go async, or whether to sort of like heal a malformed request or interpret it strictly. And the way I would imagine this playing out is I would begin by thinking how I would want the resource to behave if it was hit with an ordinary browser versus an API client. So again, I see this header as like a powerful way to reorient the design of web-based systems around resources, which are like authoritative places to go, or like things, just so happen to be in certain places, I should say, for this or that piece of information. And then the way that information is represented is merely tuned to the dialect and the preferences of the thing requesting it. And then on top of all of this, there is the fact that an information's resources representational state can change over time. There is an informational RFC 7089 that published a little over a decade ago with a header to control this called accept date time. It's basically like, give me the resource as it was at this instant in time. So not asking for a specific version exactly, but it's asking for like, it's pretending that this happened, or as if it was yesterday, kind of a thing. So I think that's kind of interesting. There's a bunch of dimensions you can mess with. It's important to recognize as well that this mechanism is extensible. For instance, there's another informational RFC that defines a header called accept features. This was supposed to be a way for browsers to advertise their capabilities to the server, and the server to advertise like what variants they had available. It would have made sense in the era when you actually couldn't be sure if the browser could render the current version of HTML, or if the PDF plugin could do transparency or whatever. It also would have been insane to implement, like on both the browser and the server. It was an RFC 2295, if you want to go look it up. It's just nuts. Like, check if you see what's on the screen. Like this alternates header would be like what you would pass back from the server. And so these could get enormous for starters, but like just like the controlled vocabularies that you would need, like the all of the, just like it would have been a mess to implement. And yeah, so, but, it's a useful exercise to think up other dimensions that I hadn't mentioned. So if you're, inclined, you can contemplate that. We're not there yet. I should also underscore, or maybe I will, yeah. It may not make sense or even be meaningful, for every resource to exhibit all of these dimensions. Like an object in a content addressable store like doesn't ever change or vary by even a single bit. Like that's kind of the point of it. But it would be useful, say, for example, to request it compressed or store it compressed or request it uncompressed, like, with a different compression algorithm, whatever. Similarly, like a JPEG doesn't have a concept of a character set and is already compressed. Also, localization is a thorny problem and probably wouldn't make sense for, say, like user-generated content. And a lot of the responses to these are going to be errors too. So like, 405 if the resource doesn't respond to the requested method, 406 if the client insists on a representation and the resource can't provide, 401 or 403, I don't have that on there. If the no authentication is supplied or the user is unauthorized. 415 is if you post something, for example, and the thing doesn't understand the media type. And then, of course, there's 300 multiple choices if the server can't determine what variant of the response you want. And then C other is sort of it's a how would I put it? It's a redirection. I mean, it is actually what it says on the tin. So all of this adds up to a thing called content negotiation, which is a spicy subject if you're not familiar with it. There are a lot of opinions around content negotiation. Also, lots of legitimate engineering concerns around it. CDNs, for example, are trepidations around it, caching in general. IPFS, of course, is because they're content addressable. Like you can't, if you have variants, how do you represent that? I have some ideas. I personally think that that content negotiation freaking rules, which is why I've put a lot of effort myself into my own work into making it manageable. Again, the reason to care about it is to think in terms of the information the resource is responsible for and then tune it for different consumers. But whatever you ultimately decide your position is on content negotiation, the point is that the HTTP specs were deliberately designed to do it. Where else are we here? Right, okay. So, two things to note about content negotiation. One is that most of the ways the resource's representation can vary can be thought of in terms of like a pure deterministic function applied directly to the bytes of some other representation. So they compose very nicely. I'm going to be doing an entire lecture on this. It's the core feature of REST that fielding called layered system. I'll just be referring it to pipes with types. I found it to be a conveniently different, terrifically convenient pattern to be able to manually override the headers with elements in the URI. By this, I specifically mean, let's see this. Where are we here? Okay. By this, I specifically mean, like I just described, like we did with localization. You have a separate handler that reads the request URI and then like rewrites both the URI and the relevant header. And then this is reflected in subsequent phases of the request. This kind of move ends up making the content handlers like a hell of a lot simpler. So yeah, I'm also going to be doing an entire lecture just on URIs, so where I will be expanding on this technique. And like maybe I'll even do like a bonus course on like just how to do content negotiation properly. So I don't think that I explicitly mentioned this yet, but you probably guessed that if a web resource is a mapping between URIs and representations, then a representation is how the resource caches out, like it's the literal bytes of the body of the response, which can be 0 bytes or not even 0 bytes. It could just be like no body. Since HTTP operates in terms of messages, a resource has to be serialized into a representation to be moved across the network. It's not just memory. So this is the thing that looks like a file, and maybe it ends up as a file on the other side. Maybe it goes into a database. Maybe it gets printed out. It's none of our business. We don't care. So when we are designing information resources, it's important to think about them in terms of what information they represent, rather than where they go on the website. You orient your design around resources. You start thinking about them in terms of reusable Lego pieces. You're like, what all are all the downstream things that can consume this? Because again, you're thinking in terms of like being the authoritative information source for any number of consumers, which is not the same thing as a web page. So an organizing principle that helps me think about the nature of a given resource. Did I? Oh my God, are we serious? I have been, just a second here. I need to lock that. How do you do that? Or just unselect it. There we go. I have been like jogging it forward, like I've been jogging this to the right every time. This is a test run, in case anybody wasn't clear on this. This is a test run. So, organizing principle that helps me think about the nature of a given resource, how to handle its representations is this 2x2. So I came up with this opaque transparent dichotomy a long time ago to distinguish between resources that were fundamentally structured data objects versus information resources that were like fundamentally a blob of bytes. A resource is opaque if there's like an original string of bytes associated with it. And I call these opaque because the system usually just treats them as bytes anyway, like it doesn't peer into it. Anything that would make sense to put into a content addressable store is like probably opaque, although not with that proto. So usually resources that begin life as a file remain opaque. A resource is transparent if its internal semantics are visible to the information system. So like this is almost always database records whose canonical representations live in memory and can typically be serialized into more than one different syntax which are semantically equivalent. So you have like JSON and YAML and you could like flip back and forth between those like forever. I mean, not strictly because YAML is funky like that, but you get the idea. Choose your favorite, CBOR and JSON, whatever. And so the other dimension is more about the representations, like a sampled versus computed. Although, not exactly, because it's, it's for you. It's useful for considering resources, but yeah, it's more important for considering their representations. A representation is sampled if it comes from outside of the system. That means if you delete it, barring certain exceptions, it's going to be troublesome to get it back. Notwithstanding like compression, like if you zip something, like you can delete the original, obviously, and then you can just unzip it again or whatever. Computed, on the other hand, is exactly what it sounds like. Like the resource itself could be computed, like say aggregates over financial data, or statistics or something like that. Like that's computed. You can just, a representation is computed like when it's derived by some other representation. This is very powerful. Again, I'm going to talk a lot about transformation functions in the pipes with types talk, but you put these together in a 2x2 and it can sort of help you plot out where the resource you're trying to design kind of lives. Another dimension or a good question to start thinking is like, is it content like or is it service like? It's a bit of a trick question because like content is like a special case of service. This is my terminology, by the way. Like Fielding gave an example in some writing about the homepage of a news website. It's like, and this is sort of why it's a little bit elusive. It's like, so how whatever instant you hit the homepage of a news website, like that's what the news is. Fielding's like, you can model that as a service whose job it is to show the client the newest homepage, which is content. So you can imagine like a CMS where like in every state of the homepage has ever been in has its own URL. Nowadays, of course, we call these permalinks. And like you can imagine another resource, which is a collection of all those home pages. And then the thing that actually serves the homepage could be a service that takes the URL as the collection as the parameter and has a rule that says, like, look in this collection for the resource with the newest publication date, and then forward the request to it. You also might want to add a check in there that it doesn't like pick one that's like dated in the future, say like an editor is working on tomorrow's issue or something like that. And then you rewrite the URL of this little service to just be the root URL of the website. So this little nano service, this like Pico service, becomes a reusable part that can go into your inventory. In fact, you could kind of put this thing in the service in a category of like pure functions over other resources. And I think this is like, I want to actually foot stomp this because, we pull down, we have no problem like pulling down like APIs from other places. Like, why don't we just, have these things in our own systems? That's kind of what this sort of idea of a layered system is about. But, again, since HTTP is just network messages, like every resource on the web is fundamentally a service. Like, therefore, content like resources can be understood as a proper subjective subset of services. To recall what I said in the beginning about information resources, these are more like thing-like than place-like. And what I mean by that, is you consider another information resource a book. A book in this case is both the physical artifact and the content that's printed on the pages. And, the physical artifact can move around in space, you and I can both have a copy. And, so I have a copy and you have a copy. I can tell you to, go and look up the third paragraph on page 206 and be confident that we're looking at the same content. So another characteristic about a book is the content stays put until you change it. So, updating the representational state of a book entails publishing an entire new version, at which point, incidentally, the third paragraph on page 206 might refer to something different or no longer exist. So a book is about as opaque as an information resource. What the heck happened? Did that just like... This like disappear. Oh, I know what happened. Oh. Yeah. Kerberos ticket. That's what happened. Anyway, where are we here? Yeah, Kerberos freaking expired. And the file system went away. That is a bug in NFS on Linux. And that is not okay. So where am I here? So yeah, what we're trying to do here with REST is tap the unique capabilities of a networked hypermedia system, again, of which the web is just one possible incarnation, while preserving this thingness property. So like where a resource is URL-wise, as we will look at in future lectures, is not supposed to be significant. Like, it's just like, not to get ahead of ourselves, but, because I will be looking at this in depth in the URI lecture, but with the web under REST constraints, a URL is just like an opaque locator. It's like, imagine a librarian writing a call number, on a piece of paper and sending you off into the stacks. The only thing that matters to you is that your book is going to be on the other end of that process. So in other words, REST, at least semantic REST, is all about what a resource is rather than where it is. Because as we will discuss in the hypermedia lection, you're just told where it is. So I want to briefly consider the conceptual distinction between a resource and a page. Like, resources are primarily things that can be conceivably in more than one place, whereas pages are very definitely a place on the website. Also, resources, at least hypermedia resources, are simultaneously bigger and smaller conceptually than pages. Like, they're bigger in the sense that they have or can have most or all of the dimensions I talked about, but they're smaller in the sense that they any composite structure is going to have a different individually addressable resource. So like, you got the resource there. You have like links coming into it. You got links going out of it. Whatever. And these are other resources. So they're smaller in this sense. These are going to all be different resources, whereas a page is going to have a structure that's kind of like, whatever. It's going to have a hierarchical structure, and like it may or may not be addressable. So to go back to this, so pages by contrast, they're almost always composite objects, nevertheless have very little to no internal addressability, just because you go about, imagine, your boss tells you to make this page. You're like, are you going to go and think about the fine-grained, it's like if you're tasked with creating the company's about page, like you're not thinking about the identities of all the little bits and bobs on the page that, the ways they can be reused. But again, we're going to talk about that in the hypermedia lecture. Composites and collections. Oh, that's it. Okay. This is where I got to, and I rewrote a bunch of the end. So this is why I'm like doing this now, because I need to figure out what slides I need left to do. But composites and collections. I'll go back to this. Not that I know what I'm going to write, but a question worth asking is like, does the resource fundamentally represent a collection? Because irrespective of whether it's intended to like represent an unordered set or a list, the representation of the collection is going to have to be put into some definite order so that it can be serialized. So you could have like a set with stuff in it. It's got to go into a list. And then that actually has to be probably truncated into a window. So there's lots of elements. You're going to have to paginate them just in order to you got to have something finite, small enough. This thing. All right. Where the hell am I here? So yeah, I think the thing about this is like, again, like you've got to have something that you can transfer over the network that's finite, or like if the guy wants to, the person on the other side needs to bail out or like not go that far ahead, you don't want to send them the entire thing. You also have to take, like if you've got a set, like with, it's an unordered set, let's say it's, so you have to have a function here that turns the set into a list somehow. And I mean, in SQL, if you're doing it with SQL, there is an order that stuff is in. It may not be the order that you want, but it has to be in, obviously to serialize it, it has to be in an order. So there has to be some function that takes that to that, and then another function that takes that to that, the window. I'll make it like that. Where am I here? So yeah, there's a similar situation with non-collection resources. Just has a bunch of items in one of its properties. So I've run into the scenario with like generated backlinks. Like if I something that I'm working on right now, if you, it's got a representation of me. And then if I'm the creator of all of these nodes, then there's like thousands of like backlinks. Like this is the, me created by me, like thousands of times. and that's just getting like disgorged. You know, it's got to execute that, and then it's got to serialize it and send it over the wire. And you know, it's making my web app very slow because I have to actually like come up with the strategy for how I'm actually going to deal with that. And I think that's just underscores like just how much of like a design issue this is. Like the reason for doing all this kind of stuff is, you know, for thinking about like web stuff in terms of resources. Like the whole idea behind it has to do with like creating artifacts like that are incredibly well-defined development targets, as well as like reusable artifacts. So yeah, but I mean, I'm going to be going over this in like the hypermedia and the data semantics. I'm going to do an entire lecture on like hypermedia as the engine of application state, like the worst acronym in the world called HATEOAS or whatever, you know, HATEOAS. Worst acronym in the world, but incredibly powerful idea. And actually the gap that I saw from reading the REST dissertation and like what all of the stuff that we have now is basically the data semantics in there and then how to go about that. But I'm getting ahead of myself. Because the other thing that I wanted to talk about is a resource as state machine. And what I mean by that is, again, I'm going to be covering this in the hypermedia and the semantics lectures, but it's useful to consider information resource in REST in the architectural style as like a node in the state machine. Because the representational state of the resource is transferred from the origin ultimately to the user agent. But when the resource is a hypermedia resource, the parts of the initial representation are interpreted to pull down more resources and add to the current representational state. So like an example of that is transclusion. Example of that is like pulling down images, you know, scripts, CSS, whatever. You are like building up the representational state. But other elements represent the set of valid subsequent states. So like I'm here, I can go here, or I can go here, or I can go here. And, you know, in the form, there are links, right, which transit to other resources, and forms, which can, you know, transfer changes to a resource's representational state back to the origin. So we have a state machine here where the transition function is the user. And so I can go here, let's say, and then, oh, there's a bunch of other ones, and like I can go here, and then like, oh, you know, okay, I can go here, and so on. And then maybe one of them comes back to here, kind of a thing. And so, you know, modeling the user flow as a state machine and then like giving each state its own URL sounds obviously useful, but it's surprisingly just how often you encounter systems in the wild that like do not do that. So like framing user journeys in terms of paths through networks of information resources puts the deliverables into one-to-one correspondence with the process model, at least as far as I'm concerned. So, you know, not only does an individual resource become an exceedingly well-defined development target, it highlights its own potential for reuse among a growing inventory of reusable components. So the question is that we don't have to answer right now, but we'll build it up over the series, is like, what do we have to do on the back end to ensure that this interface, this load-bearing fiction, remains consistent? And like, if an information resource begins life as a file on your hard drive, like transferring it to the web gives it new properties. But those properties are going to be downstream of like what kind of file it is. Like, you know, say it's an image, it would be useful to be able to automatically serve it in different file formats. So you could have this, you know, infrastructure that would just do that to every image on your website and not have to think about managing all those files. Of course, there's stuff that does this, but I'm talking about like taking a more systemic approach. Another issue is what happens, you know, when a resource gets updated or deleted for that matter. a file on your hard drive, unless you take precautions like backups or version control, you overwrite it. I'm just going to go to here. There. You overwrite it, and the old version is gone. So, we have an opportunity here to remediate that. We just arrange for all opaque resources on your system of a version, or rather like a timestamp dimension. Okay, cool. Now, what about transparent resources like database records? Well, if you're backing those records onto SQL, you're going to have to implement all that by hand. So that's something you're going to have to budget for. It's worth digressing for a moment on like why destructive updates are even a thing. Like the short answer is because storage used to be scarce. Rich Hickey has a great line in a keynote of his called The Value of Values, where he's like, computers are 1,000,000 times bigger and faster than they started out. Like imagine if your car was 1,000,000 times bigger. And that was a while ago, because like now it's more like 10 million. So now we have all the storage space we could ever possibly want. So like, why would we ever put up with destructive edits? And this principle extends to deletion. Like once upon a time, we deleted data to save space, but there's other reasons to delete a resource off the web, like making sure nobody can access it. I bring this up because there's a response code for that situation called 410 gone. Unlike the 404, which is basically telling the client, like, I don't know what you're talking about. 410 acknowledges that there was once a resource at this location, but now there isn't. And to make that work, you're going to need to keep a record of every resource that has ever been exposed. And that data is going to be absolutely sacrosanct. It's a doable thing, but it involves completely overturning how websites are made. But that's kind of the point of this lecture series. Like, file systems go back before computers. SQL databases date back to the 1970s. Both of these common constructs were used to bootstrap the web as we know it. They nevertheless were invented when computational resources were scarce, or in the case of files, non-existent. Like even the concept of CRUD, which dates back to 1983, is pretty quaint and parochial. Like, why? Because it's taken from the point of view from the database instead of a node on a network. Like, create, like, how did you know that the record didn't already exist somewhere else? For all you know, you're just storing another copy of it. Like, okay, read, sure, whatever. Update, well, we just covered this. Like, what happens, when to the previous version? Same goes for delete. Like, do you acknowledge there used to be something there or not? And so we have the opportunity, given our vast resources, to look at the Platonic ideal, of what an information resource is, and then like design around that. So in the next lecture, which I trust you'll benefit from, is about the hypermedia constraint. Actually, probably not. I'm probably going to do the URI one first. Then I'll do the hypermedia constraint. But yeah, it's one of the more brilliant but overlooked features of REST, possibly due to the unfortunate acronym. See you then. And that's it. So where are we at with the timer? Where are we at with the timer? 1:15. That's probably a bunch of junk in there. So yeah, clear to me that I am going to need to, I'm going to need a few more slides. I'm going to go back and watch this again with that in mind and do like a playback. Also, the Kerberos ticket cropping out NFS was not welcome. And the arrow key. My God. It's funny because it's like the binding, and it's like you think that the binding would just override the binding, but no, it does them both at once. So that's cute. You think like I went and I bound the hotkey to the slide thing, and I didn't realize, like, I thought it would replace what the thing did on that screen. It did not do that. So, yeah, I mean, if it ends up being a full hour and 15 minutes, like, I don't really care. I don't think, I mean, I was originally targeting 45 minutes. But yeah, I definitely need like a few more slides. I need, like when I was doing, like, it's hard to say, like some of the stuff, like it's useful to have stuff be on the paper like this, but it is, I find sometimes like it for some of the things, like I started out with it, I was like, oh, you know what I'll do is I'll draw stuff, but as I'm doing it on the fly, like basically like I can't draw fast enough, and so then it's like, am I drawing stuff ahead of time? I don't know. But like doing slides, I mean, it's not like I'm trying to convince, like I'm trying to communicate rather than pitch, most of the time. And so, you know, if I'm going to go back through that, that's probably going to be my focus. But yeah, I think I need a couple more slides and then I'm good. And then I will try, when I'm not sick and snotty, I will actually record this thing for realsies. But I am reasonably satisfied with this as it is. So I hope you got something out of it, because I'm going to be selling these for money. Once I polish it up a little bit more. I'm going to stop streaming now and finish my coffee. Ciao.